This is a presentation on ozone CCI, so this is ESA's climate change initiative. And I'm presenting this as a lead of the team. It's a big team, and I increased the font size of the team members involved with limb and occultation data. There is more to the limb and occultation in this project, as I will mention. So the rest of the team is at the bottom of the screen. So this presentation will be on the limb part of our project. So ozone CCI is one of the projects that is part of the CCI program that started in 2010. So in the early years, we had quite important resources to develop new products on ozone in this project, but other ECVs have been developed as well, so in different domains, atmosphere, land, etc., etc. The program will continue, so I will present results of the current phase of the program that ends next summer. But after that, in the next 5 to 6 years, there will be a follow-up program with a different name, unfortunately, so we will have to rebrand everything. But it will be known as Climate Space, so there will be continued activity in the next few years, which is good. So, ozone CCI. This is a table with the products that we are currently working on in this phase of the project. So, we started last summer and we will end next summer. It's on different domains. In this talk, I will mainly focus on the limb occultation data sets. So, this is a number of data sets that I will mention today, and on the limb profile, and at the bottom in green I show some products on tropospheric ozone that require limb data to be produced. I will not talk about, for instance, total column data. There is a data set by KNMI that assimilates total columns back to 1960. I will not talk about nadir profile retrievals by UV visible and infrared instruments by RAL and ULB. I will not talk about the merged time series emanating from or using those level 2 profiles. This is work by DLR, or the merged YASI time series. This will be a new product as well. And then finally, there is also development on tropospheric products. This was part of the project until 2016, but due to lower funding levels, we were unable to develop 5 years ago, continue this development 5 years ago. So we picked this up for this phase. So we will have new tropospheric products. Data release foreseen next year. I will, at the end of this talk, mention where to get those data. So first, part of the talk is on some recent results, so emanating from last project phase. This is work by FMI, where Victoria has updated a merged monthly zonal mean data set, which is quite well known in the community, used for the trend assessments. So the original version of this data set contains 7 sensors, limb sensors. And in the update, she included not only new sensors, so SAGE-3 on ISS and POAM-3. These sensors help to expand the spatial coverage. Not only she used an additional retrieval algorithm for the OMS measurements, so here the Bremen algorithm was added, and this helped to extend a bit further down the profile. And then for a number of existing sensors, the version was updated. So these are basically the changes to this data set. So the new data set has better coverage of polar regions and UTLS. And when you look at the trends, so this is at the bottom, trends as a function of altitude and latitude for the old version and the new version, they don't change by a lot. So the scale is plus minus 1% per decade. Most of the changes are occurring at higher latitudes. So also important, CCI program is meant to develop products, but mature products that are of value to the climate community are then transferred to a European Commission program, Copernicus Climate Change Service, which implies that these products are extended in an operational fashion. For limb products, this is typically once a year. So for assessments of users, this is really helpful. You don't have to ask the data provider, can you please make me a new version? There will be one every year. This is a second product that is part of this C3S operational system and developed within CCI, and this is further developed, as I will mention in the next few slides. So this is recent work on a lat-lon gridded dataset. It starts in 2001. Before, you simply don't have enough measurements to be able to do this higher resolution dataset. And in this presentation, in this talk, in this paper by Victoria, she not only explains how the dataset is constructed from six instruments, but also derives trends, and these were also part of the recent assessment. So for instance, in the upper stratosphere, there is a sign of different trends over Siberia and the North Atlantic region and Scandinavia. And a bit lower down, at 20 kilometers, there is sign of positive trends at mid-southern hemisphere latitudes, while not so much elsewhere. This was also a first attempt to do this type of dataset in the polar regions. So this was past results of datasets produced in the previous phase. Now I will turn to what we are actually currently doing. So our first set of products is on stratospheric ozone profile. So one of the important running sensors is OMS limb profiler. As you know, many teams are working on the retrieval of this sensor. There are 3 algorithms, part of our project. The Bremen team is working on one of these 3 level 2 retrieval algorithms. So just recently, the NASA team has improved the level 1 data, and this slide is showing how this affects the level 2 ozone stability with respect to Aura MLS. So you can clearly see a positive drift of OMS limb profile data versus MLS. With the old level 1 version and with the updated level 1 version, there is a change in the trend of 2% per decade, which is enormous given that trends at 42 kilometers are about 2% per decade. So by having this improvement, this clearly helps to build confidence in using this data set for trend analyses. And as part of this phase of the project, we are looking into building a merged Skiamaki OMS time series. This has already been done with Skiamaki and OMS on the Suomi platform, but the second OMS instrument will be added in a short while as soon as the retrieval was adapted to this specific sensor. It shouldn't be too much of a challenge, since given that the sensors are very similar. But the idea is, as soon as we have level 1 data, the level 2 retrieval can be run. And then, depending on the overlap, these 2 data sets can be either combined easily, or we will need to find a more refined way of combining those. But the idea is to have this one-time series of these sensors. Another line of development by FMI, so previous slides were work by Bremen, by the way. This is work by FMI on improving, so to say, the level 2 profiles. So HARMOS is a very interesting data set for people working with individual profiles. So it's a harmonized database of limb profiles for individual sensors. But this is taking the next step where the profiles are actually homogenized. So we use Aura MLS as a reference, and at each month, the bias, the difference between each of the sensors to MLS is taken out, so to debias the data sets with respect to MLS. And then in a second step, you also correct or adjust the uncertainties coming with the data products. So here, at the monthly level, the data are binned, and you look at the sample variance. You use a model to estimate the natural variability, and then you get a posteriori uncertainty for this monthly mean value, and this can then be used to offset the reported ex-ante errors to arrive at a corrected uncertainty estimate. So this is shown over here on the right. The original errors are shown here, and they are reduced by quite a large factor and should be more realistic for this particular example. So this will not be an actual product that can be downloaded from the official website. I'm sure if you are interested in using this, you can contact Victoria to find out how to obtain these data. But the official product will be a high-resolution level 3 data set. So the homogenized level 2 data will be used, and then using CLAM model and the Kriging interpolation approach, the whole domain will be filled at 1 by 1 degree resolution and for every single day. So this was developed as part of the Sunlit project, but in this phase of CCI, there will be new data versions for MLS, OSIRIS, MIPAS. A new instrument will be added, and also the time series will be extended in time. So this is a new product that will arrive in 1 year time. And this is also a product that is used for the tropospheric ozone that I will talk about right now. So second line of products involving limb and occultation data is tropospheric ozone. So these are all based on the limb nadir matching technique, where you basically take a total column measurement by a nadir sounder, you take a limb profile measurement, and then you integrate the limb profile over the stratosphere. You subtract both, and you have the leftover bit, which is in the troposphere. So again, this was developed earlier by Victoria, where she develops a monthly mean 1 by 1 degree tropospheric column product, where the top level can either be the tropopause or a bit below, depending on your needs. And there are two data sets that will be provided. So the OMI limb was produced as part of the project. So using the OMI nadir sounder for the total column bit. And then limb here means the homogenized level 3 gridded data that I just talked about. So this includes data from 6 sensors. Gap field 1 by 1 degree daily. So this is a bit of a different data set than what is existing on the market, so to say, where mostly often it's just one nadir sensor, one limb sensor. Okay. So OMI limb will be one product, and then a second product will be GTO limb. Some of you may know the GTO total ozone data set, also massively used by the assessments. GTO is using also the GOM type instrument time series, so many instruments for the total column part. So this will be an interesting addition where you use multiple nadir sounders and multiple limb sounders to arrive at the tropospheric column product. And then the Bremen team will also work on the same technique, but using data from OMS nadir mapper for total columns and OMS limb profiler for the stratospheric column. And this is an example of one map where you have some interesting features. I believe Carlo will discuss the feature over here, which is an artificial blob of higher tropospheric ozone. And this is due to some artifact in the limb profile. And this is where Carlo will talk about, I believe, on Thursday. On Thursday, yeah. They have also compared to SONS and other instruments with satisfying results. Last part, validation. All of the new products, so tropospheric ozone is kind of a new product for us in the project. These will be intercompared. This is just a map of longer-term mean tropospheric columns derived using different techniques. And these are time series. So all of this will be validated, and if this validation turns out well, these products will be transferred to operational mode, so to say, and they will go into the climate change service. So if you're interested in working with these data, level 2 and some of the level 3 products are typically available at the Ozone CCI webpage. So you can go here, or you can email us or someone in the team to get these data. For the operational products, so this is a subset of what is done as part of CCI. So these are only level 3 products. They are available at C3S in the data store for everyone to download. And this is it. Thank you.